can just check this on. Awesome. Thanks, Kev. Today's talk is going to be about step functions in C# and state machines. Doesn't matter if you don't know what these are. We'll go into all this in a second. But before we get started, I want to kick things off with a little story. And our story starts on the 6th of October, 1829, and the opening of the Liverpool to Manchester Railway. Liverpool and Manchester, as I'm sure you know, are two cities to the west of here, about 35 miles apart. And in 1829, they built the world's first intercity railway between these two cities. Now, the original plan for the railway was to have like cable-pulled trains coming along like a massive cable car. But a bunch of engineers got together and they made a proposal. They wanted to have a steam engine that would sit on the rails, connect to the carriages, and pull it under its own power. Now, steam engines did exist, kind of, in 1829, but there was nothing in the round that could pull a train all the way from Liverpool to Manchester and back again. So what they did is they held an engineering competition. So that one of the world's first hackathons, basically. And it was called the Rainhill Trials. And they invited engineers from all across the country to build a steam engine that could potentially pull a train from Liverpool to Manchester and back again for their new railway. So these are the rules of the Rainhill Trial. Each engine that competed had to be able to pull a train that was 3 times the weight of an engine, and it had to make it all the way from Liverpool to Manchester and back again. So that's a distance of 70 miles. The average rate had to be at least 10 miles an hour, and that's because the canal boats went about that pace when they were being pulled by a horse, and the whole point of the railway was it was more efficient and it was faster than the canal. So they had 10 entrants from across the country. Only 5 of them actually managed to turn up. So I'm going to take you through those in reverse order. The 5th entrant, the one that came 5th, was called Cycloped. Now this steam engine, this is a picture of it here, this steam engine was actually disqualified before it even had a chance to go on account of it being a horse and not a steam engine. And even if it wasn't disqualified, it wouldn't have mattered anyway because when they did try and run it, the conveyor belt broke and the horse unfortunately fell through. So that one didn't do very well. 4th place was this. It was called Perseverance. Now this was a steam engine. Unfortunately, Perseverance had some transport issues and it got damaged on the way to the trials, so they never really got it working. It was a bit like Robot Wars, where it gets damaged in the first fight and they just couldn't get it going. So they actually received a consolation prize of £25. 3rd one did one. Now this is a replica of it. The 3rd one was called Novelty, and this was basically a road-going steam coach that they put onto the rails. This was the fan favourite. But unfortunately, what of it not being designed really as a steam train, it just didn't do very well. It was constantly breaking down. It was a really bad design. It had a lot of quite intrinsic design flaws. So that one came 3rd. 2nd place was this. It was called Sans Pareil, which is French. Does anyone speak French? No, it's fine. It means without equal. This thing was massive. It was 4.32 tons, and it had a top speed of 16 miles an hour. And this one was all right. It sort of did it. It broke down a little bit, but it was kind of getting there. However, it only came in 2nd place because the 1st place in the Rainhill Trials went to an engine called Stephenson's Rocket. Now, Stephenson's Rocket was the same weight as the previous one. It was 4.3 tons. But this had a top speed of 30 miles an hour, which was literally the fastest thing anyone ever made, right? 30 miles an hour was incredible in 1829. People thought back then that if you went faster than a galloping horse, all the air would be sucked out of your lungs and you'd die. Like, it was really quite incredible when this came out. And as a bit of an aside, this is the birth of the Industrial Revolution, right? And people were scared. People were scared of these new technologies. It's a little bit like AI at the minute, right? Like, a lot of people think AI is going to swoop in and kill us all. Didn't happen. Everyone survived. It was fine. However, you know, these things did kick off the production of a lot of noxious gas into the atmosphere, which 200 years later we are starting to feel the effects of. So maybe in 200 years' time, we'll feel the effects of AI. But anyway, this talk is not about AI. This talk is about steam trains. No, it's not. It's about C#. So one of the reasons why Stephenson's Rocket was so fast for the same amount of weight was down to a number of innovative design choices. And one of those we're going to concentrate on today was the design of the rocket's boiler. Most steam engines had the fire, the air coming from the fire, going through a big tube through the middle of the boiler to heat up the water, and that's what creates the steam. For the rocket, what they did is they split that fire tube out into lots of small tubes, and that massively increased the surface area that could be used to transfer the heat into the water. It created a huge amount more steam, and it allowed it to go over twice as fast as the other ones, right? And I hope you can see the analogy here. This is the general principle behind functions as a service and splitting out your architecture, okay? So on the left here, we've got a monolith, which is one big fire pipe going through the boiler and trying to heat up as much steam as it can. On the right, we've got individual functions here and there, message queues, API gateways, little pieces of our infrastructure that all add up for a much larger surface area, which can, if used properly, massively increase the efficiency and performance of the system. Obviously, there's drawbacks. It's much more expensive. If anybody works in security, you'll know that a massive surface area for security is always a bit of an issue. So these things are trade-offs. It's about using the right tool for the right job. And we are going to be concentrating on the right-hand side today. We're going to be concentrating on building systems that are composed of lots of small individual parts that can be deployed separately, they can be built separately, they can be versioned separately, they can be worked on by separate development teams, and they can scale a lot easier. So today we're going to look at what are AWS step functions, what are some use cases of step functions in real life, and I'm going to show you a demo of how you can create step functions in C#, and then we're going to look at some of the pros and cons of step functions and how you might apply them to things that you're doing today. This is me. I have this book, which we can give away with your Wheel of Fortune later on today. I also have a YouTube channel. If you enjoy train analogies to coding, then my YouTube channel is called Train to Code. I am an engineer manager at a company behind the Fat Cat called Pendo. Before I was an engineer manager, I was a software engineer. Before I was a software engineer, I was an industrial control systems engineer. Has anybody worked with industrial control systems, like PLCs, that sort of stuff? Right. Industrial control systems are essentially giant state machines, right? So you have a switch somewhere in the factory, you click the switch, that sends a signal into an embedded controller. The embedded controller has some kind of function that is triggered when you run this. There you go, that's function. And that will turn on some kind of output. So you have an input, a function, and an output. And there's two ways you can think of this kind of flow. You can think of this forwards, as in like cause, function, and effect, or you can think of it backwards. You can think that every output can be represented as a function of its inputs. So every output state can be referred to as some kind of function of the state of its inputs. And what happens in industrial control systems is you get these things linked together. So one input, function, output, the output gets read into another input, which goes into another output, and there's another input somewhere, and you build up this big web of inputs and outputs, and something triggers, some event happens somewhere in your factory, the whole system falls into the next state, and then the thing carries on going. In every factory that I worked on, at least, you get one of these, which is called a cause and effect matrix. Now, these are real things that all the factories that I worked on had, and they list out all of the inputs down the left-hand side and then all of the outputs at the top. And the grid shows you the states. So it shows you if all of these outputs are on, these inputs are on, these are the outputs that are on. And when we used to commission these systems, we'd actually have to go and bring out these big pieces of papers and check every single state was working. It's very boring, but that's one of the reasons I got out of it. So with modern web applications, this sort of thing can be thought of as the inputs and events can be things like a file has been added into a cloud storage bucket somewhere, right? Or an HTTP event. This is the API gateway signal. So maybe your event is an HTTP request comes in, or an email sent to an endpoint, or anything that triggers an event in your state machine. And then the functions, here these are Lambda functions, but any kind of functions happen and create more outputs, and the system settles into the next state. So this is a serverless system. Serverless is a marketing term, really, especially when you have cloud functions and stuff like that. One of the big things that people say about serverless systems is that yeah, they're still servers, okay? There are still servers, but I like to think of serverless systems like wireless chargers, okay? So wireless chargers, this is a wireless charger. Wireless chargers have the same number of wires as non-wireless chargers, right? But the part that you're interfacing with is wireless. So that's what serverless means. Serverless means that you don't actually interact with any servers, even though obviously, yes, there are a lot of servers happening behind the scenes. So that's serverless, and that's Step Functions is a serverless system. And there's some other AWS serverless services. So we've got things like AWS Lambda is the way that you can run logic serverlessly. SNS, SQS, these are serverless message queue and message notification systems. API Gateway is for serverlessly building APIs. So the HTTP requests come in and they trigger your system. Cognito is serverless authentication. CloudWatch is logging. DynamoDB is database. Kinesis, all that sort of stuff. This one down here is what we're going to look at today. This is step functions. Step functions are a way of orchestrating a lot of serverless functions all together, and it's just a much easier way of managing. If you think back to that boiler with all of those pipes, one of the massive drawbacks of that is managing all of those pipes and keeping it all in sync and making it all work as one coherent system. So to access AWS step functions, you can just go into the console and type in step functions, and you end up with this view. And what we've got here is we've got a JSON representation of your state machine on the left-hand side, and then AWS in their console creates this kind of graphic for you that shows you what the individual tasks are inside your state machine. So the boxes here are what they're called tasks in step functions. A task could be like a Lambda function, or it could be, there's like an if statement there, so like a choice is a task. There's some very basic logic you can put inside the state machine. They can be things that send off to SQS message queues. There can be all sorts of things. Primarily, we're going to concentrate on Lambda functions today, because that goes back to our analogy of having events being triggered and then Lambda functions executed in the cloud. So these are some of the use cases for AWS step functions. Highly asynchronous workflows, right? So you probably don't want all your business logic put in this kind of really elaborate step functions state, but there are a lot of asynchronous use cases where if they're highly, highly asynchronous, this can be really beneficial. So for example, translation flows. Where I work, we use a service called Transifex. Transifex is for if you want internationalization on your product, what you do is you create a dictionary of all the words in English, and then you send that off to a translator. That could take them several days, several weeks, and they go through all of your translations. And once they've done all that, they click in their system, okay, I've done this page of translations, and then eventually, like, that will trigger something else in your back end, and eventually you'll log into the platform and you'll see it. So it's incredibly asynchronous, and it's really, it can stick in one of these states for quite a long time. So step functions are a good use case for that sort of thing, because they let you build these really, really elaborate asynchronous systems. Anything that involves a human in the loop, so translations also, there's a human there doing the translations, but you might have something like a confirmation email that gets sent out. So it could be that you built a system where it sends an email and you need a code or you need a link in that email. A person can go in there and that can trigger the next step. So you go through this step function. Maybe they don't click it after a certain amount of time, so it triggers into an error state, that sort of thing. Long-running workflows. Long-running workflows could be something like video processing or anything where you have, maybe not instead of Lambda functions, but you have some service like whirring away, doing something, building something. And when it's finished building something, you might, for example, have a video processing platform where you upload a video and you have a bunch of different services that are like changing it into different formats or putting it into different encodings and stuff like that. And then they all come together at the end and they say, yep, we've reached the end of our state machine, we're in the next state, which is the video's been processed. Scheduled workflows, again, if you need to schedule anything, there's a bunch of ways you can schedule jobs in AWS and all cloud platforms. But step functions lets you do that. It lets you trigger these based on like once a day or once a week or something like that. So there's a bunch of different use cases. Today's example is going to be a static site generator. So the use case for this is going to be, we've got a website and it's publicly accessible, and we want to regenerate that website based on something changing in the back end. So here is our static site that we're going to be generating. This is a band website for a fictional band called the C Sharps. And the way this works is you go onto their homepage, which is index.html. And on the homepage, you've got a list of all the songs that they can play. You click on a song, and that takes you to a web page that's got the HTML for songs, for the lyrics. So this is made out of one HTML file for the index page and then individual HTML files for the individual songs. The infrastructure or the architecture diagram for this looks like this. There's an S3 bucket, which is like a cloud storage bucket. And in there, you've got an index HTML file, and you've got these individual song files. And you've also got like a CSS file in there and the image assets, anything like that. Basically, everything you need to view this website is in this HTML bucket. And the HTML bucket is exposed to the outside world via CloudWatch. No, not CloudWatch, CloudFront. So it's via CloudFront, and then visitors can come in and they can view all this data. So this is a static website. And this is like GitHub pages or Netlify or anything like that, right? It's a statically served website. It's driven by another S3 bucket. The other S3 bucket has the individual songs. So if you remember, like there's the lyrics to each set of songs. Each of those is a text file. And what happens with our static site generator is you will add a new song in here. So maybe the band have written a new song and they're going to put it on their website. Put a new text file in there, and that triggers, so that's our event, triggers our static site generator in .NET, which creates an HTML file for that new song. So this is a little bit like an ASP.NET web application, but instead of responding to HTTP requests coming in, we're responding to changes in the data store. So we're regenerating the website when something happens in there. You can think of this like a database, this S3 thing. So we're saying when something happens in the database, we're regenerating our static website, basically. So we're going to build this. We're going to build this with step functions, and we're going to build this in C#. Before we get into this, the AWS Toolkit is what I'm going to be using for this. The AWS Toolkit is an extension for Visual Studio that lets you call AWS services, and a bit like how in Visual Studio you can use Azure, so there's quite a lot of functionality in there to deploy to Azure. If you install this extension, then you can do all of that, but with AWS instead of Azure. So it's got a bunch of features. It's got this Explorer window which you can open from Visual Studio. So that lets you view all of your cloud services and things. You can see your S3 buckets and all that sort of stuff. It's got credential management inside it, so you can do that directly inside Visual Studio. That's like your API key and stuff. And it has a bunch of publish tools. So when you right-click on your project, which we'll do in a minute, you can publish it directly to AWS from your project. It also has project templates. So when you create a new project, it's got a bunch of built-in templates, and we're going to be using one of these in a second. But this is a really, really, really easy way of just creating a Lambda function in .NET. I think there's probably been a bunch of other talks about how you can just build a Lambda function really quickly. This is probably the quickest way of doing it. You just use a project template. It's got a shell function in there. You put your code in there, right-click, publish to AWS, and you're done. It also has, this is the right-clicking, sorry, that I was talking about. So you right-click here and you just do publish to AWS. So obviously, this is all available on the command line, but it's a much better demo if I show you this visually inside Visual Studio. So the first step of building our static site generator is to have the infrastructure. And the infrastructure, which is going to be those S3 buckets and things, is using something called the serverless application model. Serverless application model is a wrapper around CloudFormation in AWS. If you've ever used infrastructure as code tools like Terraform or anything like that, it's not too dissimilar to that. You have a template file, and then you deploy it, and it works out, it diffs what's happened in your template file with the cloud, and it pushes your functions out to the cloud. And then we're going to create a Lambda function to start with. And what we're going to do is take that Lambda function and turn it into a full state machine. So here is our infrastructure again. And what we're going to deploy in Service Application Model is these S3 buckets. So we're going to deploy the song bucket. We're going to deploy the HTML bucket. And we're going to make that HTML bucket open to the world. You can do all of that inside SAM. And then we're also going to have a Lambda function on here. My little thing works. Here you go, there's a Lambda function. The Lambda function is going to be our static site generator. So it's going to listen to new files that are being added into this song bucket. So like I said, the band have got a new song out. They put the song into here. It listens to that, and that triggers it. And then it renders the new HTML page. So they put in a song name, and the Lambda function will do the rendering. And then it'll put that HTML page into the HTML bucket, which will make it available to the outside world. So here we are deploying it. I've got a little video of this because live demos are awful. So what we're going to do is add a new project, and this is using one of those project templates. So if we use the AWS application, serverless application project template, that will give us an example SAM template, and it will give us an example Lambda function. And if we look down here, we can select simple S3 function. So what that will do is it will create a Lambda function that's linked to an event in S3. So you've got an S3 bucket, and when a new file is added into that bucket, that will trigger our Lambda function. And that's what this project template gives us. So if we create that, it's way better than doing it live. Okay, so this is what it creates for us. So we've got this is just some default tools where you can put in API keys and stuff if you want to. The serverless template, which we'll get onto in a second, but this is our application model. This is all of our infrastructure as code, essentially. And then we've also got this functions.cs, which is going to be the code for our Lambda function. So it catches up. Here. So in here, we've got the boilerplate for a Lambda function. You can see we've got a function handler, And this is the bit where it's getting the data from S3. So that's all been added as part of our template for us. So this is going to be the base, this is going to be the backbone for our static site generator. Cool. This is the serverless template file. So if we look in here, you've got some parameters that I've defined where you can pass in the names of those buckets. S3 bucket names in AWS are like globally unique, so we can't all have the same bucket name, so you put those in as parameters. And then down here, we've got 4 resources. And these are 4 things that are going to be created inside AWS once we deploy this. So we've got, so we've got in here, we've got the song bucket, which is where our song text file is going to go. We've got the HTML bucket, which is the one that's publicly accessible. We've got the HTML functions, that's our Lambda function, and then a bucket policy. By default, S3 buckets in AWS are not accessible to the outside world. It's a huge security hole. A lot of companies have been caught out because they have S3 buckets that are publicly accessible. So it's really hard deliberately in AWS to make an S3 bucket publicly accessible. So what you need to do is you need to explicitly add a public policy on there that says it's okay for people to read files from it. So that's the serverless template, and that's going to create this infrastructure here. So it's going to create the song bucket, it's going to create the render function, it's going to create the HTML bucket, and it's going to make that HTML bucket publicly accessible. This is the code for the Lambda function. It's quite a lot of code on a screen, but basically we are saying get the object, get the song file from the S3 bucket, render it using a public package called Scriben, which is like an HTML templating engine inside .NET. And it works very well in Lambda. We're going to render that, and we're going to put it into our second bucket, which is the HTML bucket. And we're going to do some logging at the bottom, and we're also going to log the public website URL. When we created that public resource policy on S3, it's going to give us like a publicly accessible URL that we can use to access our website. So that's just going to post like, this is the URL for our new page. Cool. Let's deploy that. Hopefully these work. Here we go. So deploying, as I said before, all right, there we go. Just move this around a little bit, there we go. Okay, so deploying, you just right click on it. Oh my God, hang on. There you go, all right, we're going now. And we put some names in. So if I mentioned before that there's like parameters in our SAM template, so these parameters are where you put inside this UI, inside the publish wizard. So I've called this HTML bucket and song bucket. I click publish. I'll keep moving my mouse a little bit as well. And what that does is it creates a CloudFormation stack. So CloudFormation is the way that AWS manages a bunch of resources all in one place. So you can see your CloudFormation stack from within Visual Studio here. And if you keep refreshing it, it will tell you the state of your CloudFormation stack. And as you can see there, it says it's state completed. And if you go into this Explore window, you can open this up and you can see that it's created these 2 buckets. So that's the HTML bucket and the song bucket. It's also created down here, it's created the HTML function, the rendering function from Lambda. And you'll be able to see execution logs in here. So when we run this in a second, you'll be able to see that in there. There's also the CloudFormation stack if you need to get back to it, so you can see the state of all the things that it's creating for you. So the next thing we need to do is very quickly a little bit of housekeeping. The HTML bucket, if you remember. Oh, the HTML bucket is going to have the index.html file in it. So what I've done here is I've put the basic page for the website. That's not being generated by our static site generator. That's just going to be an HTML file. So that's the index page. And what we'll be able to do is go into the properties of this HTML bucket and go to the website tab. And what we've got here is by having that public policy, it's created for us a public website that will let you access this S3 bucket. So if we click on that link, that will take us to a new website. And you can see it's the HTML file. We haven't got any songs yet, but this is the page. This is just that one index.html file. I do have all this on GitHub. I would encourage you to go onto it because it's got all of my ChatGPT generated songs about C#, so that's quite fun. And the next thing we're going to do is look in this song bucket. Now the song bucket is the one that's like the database, that's what's feeding it all. So inside here we can add a new file. And if we add one of these song files, which is just a text file, what that's going to do is adding that in is going to have triggered our Lambda function. So if we refresh the logs, you can see that there's a new execution of the Lambda function. And you can see there that it's created our HTML file and it's given it a URL. So inside the logs here, we'll be able to copy this URL and put that back into Chrome. And that should be the song page of the song that we just uploaded into the song bucket. There we go. So that's been created by our static site generating Lambda function. And you can add all kinds of text files in there, and the Lambda function will just take that text file and it'll put it inside this HTML template, and it'll make it publicly accessible on the web. So that's the first song. Right, so this is what we've just deployed. I'm just going to recap on this. We've got the song bucket with some text files in it. We've got a Lambda function which acts as a static site generator, and that creates HTML files and it puts them into our HTML bucket. Now this is still just a Lambda function. We haven't really talked about step functions yet. So what we're going to do now is take this Lambda function and replace it with a step functions state machine. So in order to do that, we need to add some more functionality. Instead of just doing this, instead of just listening to songs being added in and then creating the HTML file for them, we're going to add in some new features that allow it to be a little bit more complicated and allows us to create a full state machine for the static site generator. So we need to add a bit more functionality, and the functionality that we're going to add is going to be multilingual support. So this is what we've got at the minute, remember? We've got a page where you click on songs and it shows you an HTML page for each song. Now, our band, the C Sharps, they sing in many languages. So we're going to have the ability to add in a song in English, which will open it up with the Union Jack on it. We're going to have a song in French here, which will automatically open it up using this French page. So these are two different HTML templates that we're using to render different pages based on what language the song is in. Now, the language detection part of this is actually a lot easier than it seems. It's done with AWS Comprehend, which is a service that just you send it off some text and it uses AI to work out what language that text is written in. And then we tie it all together and we use different templates based on what we want to do. So we're going to replace this Lambda function here with a state machine. And the state machine, this is that UI you saw earlier on. The state machine is going to do this. When it gets triggered, it's going to read the lyrics from S3 like it was doing before, and then it's going to detect what language it's written in. So it's going to send it off to AWS Comprehend and get back and say, yes, this song's in English, this song's in French, this song's in Spanish, whatever it is. And then it's going to have a choice. So that's like an if statement inside the state machine that says, like, do we have a localized version of that? You know, have we got a French HTML page? And if we have, it will call a Lambda function that renders it in French. If we haven't, we'll default back to English. And then once we've done that, we'll conflate back and go back into the end state of our state machine. So this is the state machine that we're going to use to build it. And that's basically just going to take the place of our Lambda function. So our Lambda function won't be anymore, and it'll be split out into this whole massive complicated state machine just for doing the state service. So if I go back into the code, what I've done is I've replaced that one Lambda function in my function.cs with these four individual Lambda functions here. So we've got a Lambda function that reads from S3. That's the first part of what the previous one was doing. Then there's a Lambda function that detects a song language, which posts it off to Comprehend and comes back. I haven't put the code for all of these, but you can check it out on GitHub, it's fine. And then we've got two Lambda functions based on what our choice was. So if the state machine comes back and it says it was written in French, then it will execute render in French, otherwise it'll execute render in English. So these four Lambda functions are all going to get deployed independently to the cloud. You don't have to have them all in the same file. You don't even have to have them in the same project or anything. You don't actually even have to have them all in C#, but we have. And that's going to build this. So the Lambda functions here are going to be read lyrics from S3, detect song language, render in English, and render in French. The do we have a localized one is going to be done inside the state machine itself, which is kind of cool. So the next thing we've got in here is the JSON that represents our state machine. So this JSON has a specific format, and you can see in here, we'll go into this in a little bit more detail later, but this is going to have like the states, and it's going to have the definitions for what each node is in our state machine. We've also got this object here called step function state. Step function state is it can be whatever you want, but this is a mutable object that's passed between each of your Lambda functions, and each Lambda function gets the same input and the same output, and it can add or remove or change properties in this object as you go. So each of these is a nullable string at the minute, and we've got like the song title and the song lyrics and the language key, and we've got some details and stuff like that. But the crucial thing here to note is that this is just a mutable object that the state machine will pass between each task, as it calls it. We've also got in here, so that's our state. We've got these two HTML files, one for English and one for French. And they are just HTML templates. That's the only difference really is that they've got different flags on them. And then we've got a serverless template, which has been extended a little bit. We'll look at that in a second. In fact, no, we're looking at it now. So the serverless template, and now, if you look, has got loads more resources in it. The resources here are the song bucket, like we had before, so nothing will change there. The HTML bucket, again, nothing will change there. And then our 4 Lambda functions are defined as AWS serverless function in SAM. So we've got the read lyrics, detecting language, our 4 functions there. And then we've got the actual state machine itself. So if I was to expand this node, it would have a reference to the JSON file, which is a definition for the state machine. So it posts that off. And then it's also got the trigger was there before, the state machine role, which gives it permissions to be able to do things, to call comprehend, for example, will need its own IAM permission. So that's defined in there. And then the policy for making the bucket public. So everything you need to run this system is defined in this serverless template. You don't need to do any clicking around in the UI, in the console, or anything like that. It's all in this template here. Here is the state machine JSON. So the state machine JSON follows a particular format where you have this states object. And inside the states object, you have these, what they call tasks. So our task here is just called read lyrics from S3. I've tried to kind of highlight what each task is doing there. And then we also have this choice type, which is down here. And this, again, it's a specific format to step functions. But this one's saying, these are my choices. And if it's this choice here, if the string equals French in the language key property on our mutable object, then we're going to render in French. We're going to go to that task. If not, then we'll go to render in English. So we've kind of got it works on magic strings, basically. So the string render in French is saying, go to the task render in French, which is down here. And then that render in French task is saying, execute this Lambda function. So the render in English task is saying, execute that Lambda function. This choice task specifically is, I'll go back a little bit. This choice task is called, do we have a localized template? So you can see that that's used in the line above it. So everything happens on the names, everything happens on strings. Just turn that on a little bit, there we go. Cool. So let's, oh, it keeps doing this. It just doesn't like me today. Okay. Awesome. So what we can do here is right click again and publish it, which I think we missed when the screen was off. And when we publish it, it will work out what the resources are. It will work out what resources we deployed in the previous step. And it will deploy all of those 7 things you just saw to the cloud. And we can find that out by going into the step functions in AWS console and going into state machines. And then you'll have the state machine here. So this is what was created from our state machine JSON. If we open that up, we can see we've got this definition tab. And definition tab has actually got verbatim the JSON that we sent it. And it's created for us this picture that I keep showing you. This picture is created automatically from the JSON with the arrows and everything like that. And that's interactive. So when we execute the state machine in a second, you'll see these boxes change color based on what it's in. So if you've created a highly asynchronous system like we were talking about before, it will stay in a certain state until the next step is triggered. Our static functions here won't take particularly long to execute, so that's not really going to be a problem. But if it was a longer state machine, then these things would sit in states for a lot longer. So this is our JSON. And then in here, this is our state machine JSON. This is the JSON that gets pushed exactly over into here. And it will validate it and stuff like that. You'll get an error if it's not the right format. And then here we go. Here we're testing it. OK. So if we go back into the song bucket and we upload a song, but this time I've got a French song here. So if you can read the lyrics in this file on the right-hand side, the song's actually, I asked ChatGPT to do something in French about zebras, I think. So what's going to happen is as soon as we upload this file into our song bucket, that's going to trigger our state machine. And the state machine is hopefully going to work out what language it was in. So as you can see here, you get a new execution. And there you go. So this is still happening at the minute. So we've managed to capture this before it fully completed the state machine. And you can see it's read the lyrics, it's detected the language, it's gone through that choice, and it's worked out this is in French. So it's currently executing the French Lambda function. And if you wait a second, there you go, it goes back into green. So that's the state machine completed. You get a log down here, so this shows you what's been happening. Like, it shows you like the Lambda functions have been called. If you get errors at any point in your state machine, then you can have like error routes as well. So you can say this Lambda function failed, so I'll drop into this failure route, which is quite useful. And this is the log event for the Lambda function itself. And if you remember, our Lambda function was outputting the URL of our new page. So that URL should be French page. So this has been created by the whole state machine going through and finding the individual tasks and going, yes, yes, this is going to be in English, this is going to be French. There we go. And then we'll go back to the index page. This index page has a little bit of code that actually calls off live to list out the bucket to work out what's going on. So this is like a dynamic bit of JavaScript that just goes off and works out what the songs are. So we haven't actually re-rendered our index page. But if you wanted to build like a really complicated static site generator, then you could rename, you could render as many of these pages again as you wanted to. So that's basically step functions. Like, that's really it. It's really not, it's not massively complicated, but it also is not massively difficult. So I'm an engineering manager, I mentioned at the start, and one part of my job is to communicate engineering stuff to the business. And one of the real key advantages of state functions, or step functions, is that it allows you to really, really clearly communicate with these pretty pictures what's going on in your system. So anybody anywhere in the business can come along and they can log into this console and they can see what's happening with your static site generator, or what's happening with your translation workflow, or your video processing. If it's gone into an error state, they'll be able to see the boxes being read. And it's a really, really good way of communicating what's going on with your Lambda functions. And it kind of solves a problem. It solves a problem of having a very opaque function as a service system by just giving it this nice kind of orchestration around it. But I've written on here, every problem is not a nail, because just like anything, these things have a purpose, right? So like, you don't want to be using this for all of your business logic because it's just massively overcomplicated. You don't want to be using this for things that need to be incredibly performant. As you saw before in that example, it took quite a long time for that to settle into the state, when all it was really doing was calling a service and doing some rendering. So again, like, everything has to be used for the right purpose. Stephenson's Rocket was also one of the most expensive engines that they entered into the Rainhill trials. I don't know if anyone saw recently, but AWS have actually moved Prime Video from serverless back over to EC2, right? So basically, AWS has decided that the scale that they're running at, serverless isn't right anymore. So you've got to design for the right scale for what you're going for. If you're doing something quite small or like a hobby project, I run a bunch of random websites for things, it can be really useful. It can be really useful for describing what's going on in your system. It can be really useful for keeping the cost down at low scale. So Lambda functions give you something like 1 million executions a month for free. So for a massive business, that's not enough. But for a small like hobby project or a small startup that's trying to get off the ground, you can basically run it for free, and you get all of this, like all of this step functions, all of this visualizations, pretty much for free. Performance, again, performance is one of those things where these aren't designed to be super, super fast. They're designed to be super visual and designed to be super fragmented, but they're not really made for raw performance, unlike the Rocket, which was wicked. I've got a YouTube channel called Train to Code, which I might have mentioned at the start. If you scan this QR code, you can go onto my YouTube channel, and I've got videos on there, not just about step functions, but about all kinds of interesting .NET things on AWS, like App Runner. I've done one recently on Azure, OpenAI, so how you can call ChatGPT from your C# code. That's really interesting. And that's it. I've got a book to give away. Should we do the book giveaway?